So, who was the greater genius, Albert Einstein or Isaac Newton? It's a huge debate, and honestly, even today's top scientists are pretty divided on it. For more than 200 years, Isaac Newton was considered untouchable. So, how on earth did his most famous idea, gravity, get turned completely on its head? Okay, let's dive in.
You have to understand, for over 200 years, Newton's theories were basically considered the absolute final word on how the universe worked. Even Albert Einstein, the very man who would eventually challenge him, said Newton was a creative genius of the absolute highest order. His work was the bedrock of physics. It was gospel.
And that's the great irony here, isn't it? The person who admired Newton so deeply, Albert Einstein, would be the one to show that his foundational theory of gravity, well, it wasn't the full story. This is the story of how one genius rewrote the work of another.
To really get what Newton accomplished, you got to picture the world he was born into. This was a time when what we call science was just starting to awaken, just beginning to shake off all these ancient beliefs that had held on for centuries. So, Newton's early life, it was rough. He was born in 1642 into a really troubled family, had a lonely childhood. Can you believe at one point his mother actually pulled him out of school to become a farmer? But lucky for all of us, his headmaster saw this incredible spark in him and convinced her to send him to Cambridge. And that's where his genius really started to catch fire.
Now, Newton gets to Cambridge and pretty much immediately realizes that the physics they're teaching is, well, it's ancient history. Literally, it's Aristotle. But Newton wasn't interested in old dogma. He was obsessed with finding the truth for himself. So he just dove in on his own, devouring the work of modern thinkers like Galileo and Copernicus.
And it's during this time, pretty much all on his own, that Newton has this unbelievable light bulb moment. He starts to wonder, what if the force that pulls an apple down from a tree is the exact same force that holds the moon in its orbit around the Earth?
This idea, what we call universal gravitation, it was completely revolutionary. Before Newton, everyone thought the heavens and the earth followed totally different rules. Newton came along and said, nope, it's all one system governed by a single invisible force that stretches across the entire universe.
And he came up with this brilliant thought experiment to explain it. Picture this. You're on a super tall mountain with a cannon. Fire it too slow, and it crashes back to Earth. Fire it too fast, and whoosh, it escapes into space. But if you get the speed just right, it will continuously fall towards the Earth, but since the Earth is curved, it will never actually land. It's forever falling. That, Newton realized, is what an orbit is.
Now, having the idea is one thing, but proving it is something else entirely. The universe is always changing. Planets speed up and slow down. To describe all of this with math, Newton had to invent an entirely new branch of mathematics from scratch. We call it calculus. It's literally the language of change.
So, for 2 whole centuries, Newton's laws were king. They predicted the movements of the planets and stars with incredible accuracy. His idea of a clockwork universe seemed absolutely perfect. But then, astronomers noticed a tiny, nagging little problem, a crack in the system that just wouldn't go away.
The problem was the planet Mercury. Its orbit was just a little bit off. Every century, its path shifted by a minuscule 43 arcseconds. I mean, that is a tiny, tiny fraction of a degree. But here's the thing. In a perfect clockwork universe, even the smallest error means the whole machine is fundamentally broken somewhere.
So what was causing it? Well, astronomers were so confident in Newton's laws that they literally invented a phantom planet. They even named it Vulcan, that they thought must be tugging on Mercury. They searched for it for decades and found absolutely nothing. The mystery just got deeper, and for the first time, people started asking serious questions about Newton's theory. The answer to Mercury's wobble wouldn't come from some famous astronomer in a fancy observatory. Instead, it came from a totally unexpected place, a young guy working in a patent office in Switzerland. A man who, by all accounts, hated the rigid ways school was taught, but who would go on to completely reimagine reality itself.
Yeah, Albert Einstein was not your typical prodigy. He was a quiet kid, didn't even speak until he was 4. He couldn't stand just memorizing facts in school. He was all about these imaginative thought experiments inside his own head. He taught himself calculus when he was 12, but he was really driven by this deep curiosity, and he became obsessed with a single, profound question. What would you see if you could ride alongside a beam of light?
And that one simple question led him to a truly revolutionary idea.
He realized that space and time, they aren't separate things. They're actually woven together into a single, four-dimensional fabric he called space-time. And this fabric wasn't just some passive background for the universe, it was an active player that could be bent, stretched, and warped by mass and energy.
And this is where Einstein completely overthrows Newton's masterpiece. See, in this new picture of the universe, gravity wasn't some mysterious force pulling objects across empty space. Gravity, Einstein claimed, wasn't a force at all.
This slide shows you just how wildly different their views were. For Newton, a ball on a table is at rest. Gravity pulls down, the table pushes up, everything's balanced. Simple. But for Einstein, that's just an illusion. He argued the table is actually accelerating the ball upwards, preventing it from following its natural path through curved spacetime.
And this leads to a conclusion that it breaks your brain a little. An apple doesn't fall because gravity pulls it. The ground is actually accelerating up to meet it. The apple is just following the straightest possible path through the curved spacetime that the Earth's mass creates. So what we call gravity is just an illusion caused by geometry. And this bizarre, brilliant idea perfectly explained Mercury's 43 arcsecond wobble. So, Einstein comes along and shows that Newton's central idea about gravity was really just an illusion. Does that make Einstein the greater genius? Was Newton just wrong all along?
Well, not exactly. The best answer might actually come from Newton himself. You see, science isn't a battle, it's a building process. Newton's laws weren't wrong, they were an incredibly powerful approximation that works for almost every situation we experience. Einstein's revolution was only possible because he was standing on the colossal foundation that Newton had already built. So I'll leave you with this final thought to ponder. As you're sitting there right now, feeling what you think is the pull of gravity, remember Einstein's insight. You are not being pulled down. You are feeling the chair you're on, or the floor beneath you, constantly pushing you up, resisting your natural free fall through the fabric of space-time. What you think of as gravity is actually the feeling of being stopped.